in this video we will prove one simple example where we prove that any integer is of the form 2q or 2q plus 1. Alright, any integer that you take, it can be written as 2q or 2q plus 1. So, this is what we are trying to prove here. So, let us assume any integer a. Okay, so let integer be a. Let there be any integer a. So, by Euclid's division lemma, what do we know? Since we want to prove this one as 2q or 2q plus 1, by division lemma, we will divide a by 2. Alright, so any integer, a is any integer, so we divide a by 2. So, when we divide a by 2, what we get? We get some quotient q and we get some quotient, some remainder r. So, by Euclid's division lemma, now tell me a can now be written as 2 into q plus r. Correct? Now tell me, what are the possible values of r? Now, r, since the divisor is 2, the remainder can take either 0 or 1. So, the r values can be either 0 or 1. These are the only two possible values of r. So, therefore, now what can you write a as? So, a either can be 2q plus 0 or a can be 2q plus 1. So, remember, a is any integer. So, for any integer, a, it can be either 2 into q plus 0, which is nothing but 2q, or 2 into q plus 1. This is what we wanted to prove. Let us verify what is it trying to say. Take any integer, take any random integer, let us say 25. Alright. So, when you take 25 and you divide by 2, correct? So, when you divide 25 by 2, it is 12 2s are 24 and 1 remained. So, this 25 is now written as 2 into 12 plus 1. See, you are now able to convert this 25 in this form, 2 into q plus 1, correct? Take some other example, let us take, let us say 30. So, when I take 30 15s are, sorry, 2 15s are 30 and remainder is 0. So, you take this 30. So, 30 is now written as 2 into 15 plus 0, which is nothing but 2 into 15. Now, you took number 30, now you are able to write it as 2 into q here is 15. So, you will, like this, you take any integer, you can always write in multiples of 2 into q and plus some remainder 0 or 1. So, any integer can now be written as 2q or 2q plus 1.